So we're just delighted to give you a full roundup of talks all around threat modeling, MITRE counterintelligence, as well as security chaos engineering. So quite a loaded program, and really looking forward to. Now, just don't want to spend too much time on it. We talked about this quickly, but just like to say, what is actually OWASP? So OWASP stands for the Open Web Application Security Projects, and actually that consists of several things, like something we do, like running a local chapter that could be in any city like Frankfurt, Munich, but also somewhere around the world, like in London. There's over 200 local chapters worldwide, so quite an active community. If you're not based in Frankfurt and you're based in a small town, feel free to consider creating your own chapter and getting your own speakers. So I think it's really good just to have this structure. And there's over 10,000 of members, also very active on Slack. So if you ever have a question about OWASP material or a project, just head to the Slack channel. I'll show this later on, the link to get invited, and just get involved. I think that's the best thing. It's just volunteers, same as Johannes and me, just organizing meetups, or just do some coding on a project, or just maybe some write-ups. Great. Now, let's talk about our program highlights for tonight. First of all, we're going to have a keynote by Christian Schneider on Agile Threat Modeling with open source tools. And he's going to show this by using the tool 3Agile. And Christian will show us how to capture the rapidly changing threat landscape of Agile projects using what we call the threat model as a code in the DevSecOps sense. I was really excited when I saw his talk on the OWASP 20th anniversary conference, and really shown how to actually codify those rules. I'm really excited for Christian's talks. In the next talk, we're going to have our all dear Johannes Schönborn talking about MITRE counterintelligence, and really looking forward for his talk, because he's going to focus on how red teams can actually use the MITRE attack methods in order to perform attacks that are either very difficult or almost impossible for the blue team to detect. Now, afterwards, and I'm really looking forward also for his talk, is going to be Aaron Reinhardt, who is based in the States. And Aaron Reinhardt is the pioneer behind the concept of security chaos engineering, pioneered by himself at Verica as well as Netflix, and is also the O'Reilly co-author on this book. And as part of his talk, Aaron's going to share his experiences and giving an broad overview over the concept of security chaos engineering. So really looking forward for his talk as well.
Right.
Great. All right, Christian. So let me welcome our key speaker for tonight, Christian Schneider. Christian has been pursuing a successful career as a freelance software developer for quite a while. I think it must be more than 20 years, quite a decade. His major areas of work are actually penetration testing, security architecture consulting, and of course, threat modeling. Apart from his main work as a software developer and security professional, he's also a trainer, and just talked about that he's been actually just joining from another conference, so be aware that his voice might be just a bit exhausted from that, but we're still really exciting just to have you here. And yeah, he also coaches Agile projects to include security as part of their process by applying DevSecOps principles. Christian, are you ready to talk?
Perfect. Thank you very much, Dan. Thanks for having me. Really looking forward to that. So let's share my screen. Well,
yep.
So let's go to the screen share and take over with desktop 1. Perfect. Okay. So yeah, thanks for having me. So I'm going to speak a little bit about Agile Threat Modeling with open source projects, and it's about some open source project I created. I'm going to speak about that, and Dan has already introduced me a little bit, so I don't need to use that slide. So basically everything that needs to be said has been said. So let's jump right in. So first, what's threat modeling? So people also name it something like whiteboard hacking. So some kind of work that is analyzing the security posture of your architecture in a security architecture way. So doing classic threat modeling in terms of data flow analysis and stuff like that, or some more sophisticated analysis of the architecture or attack tree based stuff. And there have been tools around that have been quite heavily used. One of these is the Microsoft Threat Modeling tool. You see some example architecture here. So it's a free tool from Microsoft that's also quite nice, but it's more on the visual side, where you start with a visual diagram. It looks nice in terms of these more simple architectures, and I think it's good to understand for those of you who are not directly into threat modeling to understand the big picture about threat modeling. But at least in my opinion, is not perfectly suited to start from a graphical tool if you're having a bigger architecture, because then sometimes things might start getting a little bit ugly. But that's a very good way to depict the overall idea of threat modeling. So you see components that are resembling your architecture, you see data flows, and the red boundary lines you see basically something that's a trust boundary. So the major trust boundary to the internet, or some other trust boundaries to some DMZ or some cloud security groups or some isolation network policies, stuff like that. So it's basically where every time when a data flow crosses a trust boundary, some kind of risks might arise. And that's what threat modeling is about, to understand the risk landscape of your architecture. So in a physical Stammtisch meetup here, we would do some hands polling here. So many people are not on every release doing threat modeling. It's more the majority, if at all, does it only on the initial project phase, to sometimes in big operations get a green light from security. And then these models from time to time, they erode. So they are losing on quality because they are not adjusted and not reflecting the changes from MVP 1 to the other MVPs of your project. And then the overall usefulness sometimes degrades as well. So, and especially in agile worlds, when you do have the necessity to do this, if you were doing it correctly on every sprint, at least incrementally adjusting the threat model. And that's, I've not seen it that many times. And also, well, what about automating this kind of thing, as we automate lots of stuff in DevOps and DevSecOps? So what about putting threat modeling also into these things? That's not that easy, because it's also about a model, about speaking, about a workshop-like setup. So at the end, it cannot be fully automated, but well, possibly some baseline things can be automated. And in DevOps, or name it DevSecOps if you want, everything appears to be some kind of automation magic. Can be code, can be some declaration of something, some declarative model. So we do have lots of testing, security-wise testing capabilities in some kind of DevSecOps scenarios, like analyzing the dependencies of your software, like doing some code scans, or even sometimes dynamic analysis. So there are very good tools available for that. And we managed in the security area to keep up with the pace of the agile development approaches, to have at least some kind of baseline security scan just on every release, on every build, and that's perfect. I wanted to take this kind of automation thing also for the threat modeling approach to DevOps. So putting DevOps into threat modeling, threat modeling into DevOps. And that's more in terms of trying to treat threat models also as something that is more or less automatable, and that can be, well, even sometimes something like code. What about threat models as code? What's the benefit of code? Well, just some benefits. It's of course editable in any IDE, even VI if you're into that, or Emacs. It's checked into the source tree. So it's living, if you want to let the model live along the code base, it's living along with the code base. You can diff it, you can revert it, you can merge it, branch it. So it's, well, code basically. It's easy to collaborate on that, more easier than some graphical tool, for example. Can be tested, can be verified. And the outcome is also something that's a repeatable process and has a reproducible result. So also something that you can easily recreate. And that's also something very interesting sometimes. It clearly states the most recent update in the revision history or the lack thereof. So for example, when your project has received lots of merge requests, but the threat model wasn't changed at that same kind of amount, then something is amiss eventually. So at the end, that the model is not really reflecting anymore the reality of the project. So that can be seen there in the revision history quite easily. And developers, at least me being a developer as well, we love code. We know the application best. So developer teams know the application best they are creating, or the services they are creating, because, well, they are creating it. That's where the truth lies. There might be some more benefits, of course. It's not at all an exhaustive list, but there are also some drawbacks. So for example, well, it's code. Someone has to write it. It's not that easy compared to just drawing a few boxes on a canvas. And some people find it hard to read. Well, I understand that, because not everyone related to the software development lifecycle is a developer. So that's definitely something, it's an argument. And yeah, it starts, that's not an easy one. It starts with the details, not the abstractions. And threat models, it's about modeling. So that means we have a model of an architecture that's not about the details. So we need to see the abstractions to depict some interesting threats possibly out of that model. And starting with the details might be a little bit not so easy to spot the big picture directly by looking at the details. Well, it needs to be addressed. And there might be some more drawbacks of having threat models as something like code, of course. So what was the idea to put threat modeling into the DevOps approach and to have something like threat models as code? The idea was to have something that is having the most of the benefits, the aforementioned ones, and at the same time, just as few of the drawbacks as necessary. And then the idea was, well, use something that's easier to create and read, like code, making it YAML. That's the most easy human readable markup language I've come up with. And it can be processed more or less in the same way, like code. It's understood by all IDEs and by software. And it's a declarative way, not that complex like code for some people might be. And understood by all IDEs. Then the idea was to put a threat model into something like a YAML file and describe in that YAML file the data assets you're working with in your architecture. So that's about data. Threat modeling usually is about data flow analysis. So you're speaking about data, not detailed in terms of a table and columns and all these things and attributes and entities. That's way too detailed. About classes of data. Health data, very, very, very sensitive in terms of security. Billing data, some just log data, or some other classes of data, because they all have different ratings in terms of confidentiality, integrity, and availability. So we can group that. And also describe the technical components of your architecture. That means those boxes that you would draw on a whiteboard. And of course, the connections. What box is speaking to what other box? So the communication links, where the data is actually flowing. And last but not least, the trust boundaries. So to have some kind of way to isolate certain components and encapsulate them against some other kind of set of components. So the typical network DMZ kind of thing, or cloud security group, or these ways where you can isolate the reachability of certain components against other worlds. And the idea was to use an open source tool to analyze that kind of model as a graph of connected components with data flowing between them. I was researching different things last year, and then at the end I said, well, I'm not really satisfied with the current state, so I'll try to create something. And it should generate, what should it do? It should generate model graphs. So definitely we need to have the visual representation. As a human, we need to see the big picture. Otherwise, we cannot easily see and recognize that we possibly missed something, or we draw a wrong connection, or we misplaced the component in the wrong trust boundary, or something like that. So we need to see the big picture, definitely. And also to come up in a workshop, if we do these workshops, still with risks that no tool can ever identify. So we need these models, definitely. And threat modeling is about threats, about risks, to get those potential risks and threats out of the model. So to get this basically as some kind of risk detection, and to provide development teams, architecture teams with hardening recommendations of how to mitigate these things. And that's for the big corporations to have some more reporting requirements checked, so to have some more documentation for the compliance folks and stuff like that. That's important stuff, but we can generate it if we have a template approach and we have the details in a model file. And that's about Agile Threat Modeling, actually. So it's about bridging the gap between classic threat modeling approaches, which is more the workshop kind of style thing, also still very useful, but cannot be done on every sprint, and the agile development approaches. So with fast-paced development and fast-paced going to production. And then actually doing these things, so describing the data assets, components, communication links, trust boundaries in a YAML file, and have them processed. So that's why I created Threagile, an Agile Threat Modeling Toolkit, if you want to name it that way. It's open source, living on GitHub and Docker Hub, MIT license, so very permissive license, open source. And it's doing exactly that. So you're modeling your threat models in a YAML file and then having that processed by Threagile. So it's a technology-aware kind of modeling. So you're providing in the model file some technical details about things like protocols, HTTP, HTTPS, JDBC, LDAP, LDAP-S, whatever. So there's a big list of different protocol types for the connections, or technology types for the components. So that's a message queue, that's a REST service, that's a load balancer, that's a reverse proxy, that's some kind of data store, that's a NoSQL database, something like that. And then there are over 40-ish risk rules. So that's a rule-based system. They are coded. And these pre-existing built-in risk rules, they can analyze the model because it's modeled in a very technical way, quite precisely, leading to just very few false positives. That's what I've seen in real-world usages. And it also has some kind of plugin interface to have custom risk rules applied. That's important to create your own risk rules if you want to do that, being a big corporation, possibly. And calculates a few values. What these values are, we've got a few slides for that later on, going to that as well. And there are model macros available. So that's some kind of question and answer wizard style thing to have certain model modifications applied to the model in a repeatable fashion. That's also something very nice. And also to maintain the risk mitigation state in the same model file. That's also very important. So not just to get to those risks, but also to have them in a way, documented how you mitigate them, or whether you accept them as being just there, or whether you're about to mitigate them. As said, released as open source, MIT license, and of course runs totally offline. Sure. Here it is. So it's a CLI, it's a command line interface, nothing more than that. And it has a REST server as well. You can start it in a REST server mode and a little bit of a web server mode. It's available as a Docker container with everything in it. So that's quite easy to run. So just can run it as a container, and then you've got the CLI. And so one of the first steps when working with Threagiles, you create a model file by either using the stub model that's provided there. That's a very simple, just one or two components in it, minimal model that you can then fill. Or you can use the existing example. That's a small filled example to have something to play with and modify with that. And then you model the data assets, technical assets, the communication links, and the trust boundaries. And then you can execute that. So here's an example. So just basically taken from the example model, some customer contract modeled here as a data asset in a YAML file. And you can provide an ID to that so that you can reference that later on. And some description for the creation of the documentation. That's more for the docs. Origin, owner, quantity. And most interestingly, for this customer contracts data asset category for this example, the last 3 rows, here are the lines, the confidentiality, integrity, and availability ratings. So there's a 5-slot rating of each of these attributes that you can rate your data assets and your data classes to these confidentiality, integrity, and availability rates. And then you model the technical assets, like here in this example, a web server. And it has also an identifier, an ID to be referenced. Some more things are selected, like whether from the classic threat modeling approach, whether it's a process, a data store, or an external entity, what type is it? Is it used for processing business stuff in the application or the architecture, or is it more for DevOps side in terms of being a monitoring stuff? Is it used as a client? A human? Yeah, obviously not. Is it possibly out of scope? If, for what reason, for what justification you're putting this out of scope? Just to have some context in the model. So there are sometimes things that need to be modeled to have the context, but themselves are not part of your architecture, so you can set them as out of scope. And some more information about the size and the technology. So in the technology thing, you can have an enum of many different technology types that you can choose from. A little bit of tagging, that's just for documentation and tags. Whether it's sitting on the internet or not. So the client, if it were a web server of an internet-facing application, then the browser being the context also modeled, what is basically accessing then this kind of web server. That would be sitting on the internet, having internet true. What kind of machine it is, physical, virtual container, serverless, how or if at all it is encrypted, and some confidentiality, integrity, availability rating, and a little bit more information as well. So not all these fields are required, but some of them are definitely required to have a good model. Then, very important, you reference the data assets that are either processed or stored on this kind of technical asset, on this component. So that's the IDs you're referencing. So data stores are storing more, obviously, and other component types are more on the processing side. And then you model the communication links. So that means the outgoing communication links to what other kind of components also being in that kind of model file referenced by the target identifier, the target ID. Is this component talking to via what protocol? Here, HTTPS. It's also a big list of possibly a big list of components to be used, protocols to be used. And Threagile is the risk rules in Threagile, actually, they understand from the protocol types whether they are encrypted or not, if there's an encryption inherent in the protocol. And you can also model the type of authentication and authorization. So is it authenticated and authorized? If by what? Credentials, tokens, session ID, certificate, 2FA, whatever. Or if it's then authorized by a technical user, or is the end user identity propagated via that connection. A little bit of more things. And then you reference the data assets that are sent and received. So you're modeling classic data flow. You're modeling the technical connection. And you can also, via having the data assets referenced in the send and receive directions, you can also have a logical data flow being modeled there. So it's important in a threat analysis to have the technical connection also modeled so that it's clear what component is calling and what component is being called, because the one being called is offering a interface, an attack surface then. And of course, you model the trust boundaries. So there are different types of trust boundaries existing in Threagile that you can choose. A type like here a cloud security group, or you can choose a VLAN or container isolation, network isolation policies, or classic physical network boundaries, something like that. And just giving it a name, well, and reference the assets that are living inside that kind of thing. Like here, web server, whatever, by their IDs. And you can even nest trust boundaries so that you can have a big trust boundary for your corporate network. And you can then have some kind of some cloud things and some other things that you can more detailed nest into that. And then you execute Threagile. So it's a CLI or REST server. So it processes the YAML file, executes the risk rules, including the custom developed ones, if you do have any, and well, creates some nice output. Here it is. So that's a simple, a very small model. It's actually the example model that's shipped with the Fragile download. So it's some very simple small one that you see. Oh, it's a nice auto layout algorithm. So it's giving us the big picture that we were otherwise missing. That's important. And here we see the truth of the data flow. The colors and the shapes, they resemble themselves some kind of risk and some kind of other information. And well, that's easy then to see if we misplace something, for example. That's a very small one, just to have something useful for the slide here. And it's creating some kind of reports. So it's creating some kind of PDF and Excel reports. So to work with, to have the actual risks analyzed and presented to you in multiple ways. So it's a redundant report having different angles, different perspectives to take a look at the risk landscape. Therefore, it's quite long. Starts with a summary, as always in life, and then an impact analysis. You can even manually add risks, individual workshop-wise identified risks to the threat model file. So here some very critical individually added risk was also there, that it flows in the same manner through the risk processing. And also the automated identified ones, that's the important point here, are there. And you have an impact analysis before and after mitigation. So that's the initial risk in landscape here in whatever kind of 28 categories. And then you've got the risk mitigation. And as said, this is also modeled inside the YAML file, the risk mitigation state. That means you do have a way to flag risks as either in discussion, as in progress, as mitigated, as false positive, or as accepted. And only mitigated and false positive are counted as mitigated or not being present anymore. The other ones are either accepted or are still there or unchecked. And that means they are still part of the remaining risks. And you do have an impact analysis here as well. For those of you who are into STRIDE, so the classic STRIDE way of having risk assessments or threat modeling is being performed, there's spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. These are the categories of the threats in STRIDE. And that's also a grouping here of the same identified risks to that category set, so that you have a mapping here. Same goes for the assignment by function. That's important if you have a result. Who or what team should handle that? To whom should I forward that kind of risk? And there are some risks that need to be addressed or at least checked by the business side, like missing two-factor authentication. So that's definitely impacting the user workflow. Or some example that was added here to the model. Some are on the architecture side, more on the development side, some, and of course also some on the operations side. And then also some nice chapter in the report, the relative attacker attractiveness, RAA. That's a nice value that's being calculated for each technical component. That's a pluggable algorithm, and the default is taking the amount of data and the sensitivity rating, CIA, sensitivity rating of these data assets on that particular component, doing it for every component, of course, into account. The more sensitive rated data, the very, very more higher that value is. It's a number from 0 to endless, infinite. And then some more calculation happens based on the type, the technical type of the component. Data storing more sensitive data is obviously more of interest of an attacker to access than just processing stuff. Well, so that's then some weight factors are calculated. And then also some adjustment happens because due to the data flow. So when there's a component having a very interesting high rated value in this attacker attractiveness score, meaning that's something that an attacker would definitely try to get to, that's from the pen testing, possibly also from the red teaming side. And you have a component sitting close to that, like a not so interesting data-wise, not so interesting monitoring sidecar, whatever component. important still, but it's not of interest of an attacker to get to monitoring data as compared to get to the ERP system's internal data. But the fact that this component, this not very interesting component, is sitting quite close and has a direct connection to the high-rated one, gives it also a bump upwards to have a higher rating there as well. So it might be the typical pathway of an attacker when pivoting into your backend to reach the ultimate target of interest. And then at the end, these numbers are then relativized to a percentage score, and then goes the RAA value. You can plug your own algorithm into that, but that's the default one, and it gives some kind of interesting, sometimes the obvious, but sometimes also the not so obvious, sometimes overlooked pointers to things that might be very interested, where attackers might be very interested in taking these. And that's giving you, if it's a high RAA score, a hint in a big architecture where you should first focus your hardening efforts, and so also possibly your monitoring efforts a little bit more to harden and safeguard them first. Also, data breach probability value is more or less calculated, but the blast impact, if you want to name it that way. Here for the example model, the simple one, the small one, you have a chart that's not meant to be read in detail. It's just giving you the conglomeration of data assets on the left side, and on the right side the technical components and how they relate. A blue line, a straight one, is giving you the sign that this data asset is stored on this technical asset, and the dashed gray ones are for being processed there. And here on the left side, that's for the data protection officer interest. On the left side, you see the data assets, and they are all red because that's not too much that has been mitigated in this example model. And on the right side, you see the technical components. The colors resemble the risks of the remaining unmitigated risk state for these components. And well, on the left side, all data assets have a probable, a red one, kind of data loss probability. And if you want to get rid of that, at least for the most important data types, of this probable data loss probability or data breach probability, going from probable to possible or from possible to improbable, that's a 3-level scale there. Then you have in this report here also the identifiers clickable here to go to those risks that, still being unmitigated, would have a high blast impact of a data breach if they are manifesting these risks. And you need to address these first to get a lower, a better data breach probability of that data asset. So it's giving you a guidance of where you should prioritize to mitigating certain risks if you're coming from the data protection side. So, for example, all these risk rules, they do have a way to assign a certain data breach probability of being improbable, possible, or probable to the technical assets processing or storing these data assets when that risk on that asset, whatever risk it is, manifests. There are risks like injection vulnerabilities, code execution vulnerabilities, stuff like that, that have a very, very probable risk of a data breach if they happen. And there are also some kind of vulnerability types or risks and threats that do not have a high data breach probability, like denial of service. Still important thing for an online shop. You're losing money, losing availability, but you're not losing data by losing availability. So that's reflected in each of these risk rules as well. And then, most importantly, you have the risk mitigation state there. So for all those different categories of identified risks, for those that have been actually identified, you do have an intro chapter, what this vulnerability type is, giving the impact, the detection logic, how it is being detected in the model, the risk rating, why it's rated either as high or not that high, what could be false positives that should be checked by a human, of course, the typical false positive thing, and a mitigation recommendation and a check question. And that's referencing as best as possible the OWASP resources, excellent resources like ASVS, Application Security Verification Standard Chapters, the CSVS or the OWASP cheat sheets. So for the developer to directly get to the mitigation steps from the reports. Then the instances of those identified risks are being written, so rated according to the sensitivity rating of the data that would be at stake. So some are more elevated or high, some are more on the medium risk or low risk side. And the risk state as well. So you can also see here whether they have been mitigated or accepted by someone or whatever. Default is of course unchecked. So nice report, quite big because it's giving you 3 different angles, 3 different perspectives on the same data. And if you're used to that, then at some time, then you definitely go more into the Excel thing, I think. So it gives you a more condensed view of the same data. If you know what's already in the report, then you can work with the Excel export a little bit easier. That's what I do many times. And of course, the JSON thing for processing it in the DevOps scenario in some kind of automated processing. That would be very, very useful if you put this into some build pipelines. More on this later. There are over 40-ish risk rules. It's constantly growing. So some of them are here written, and it's written in Go, very, very nice language, very easy to create something with. Here you see the LDAP injection rule, for example. On the left side, you see the documentation fragments for the report and the rating and stuff like that. On the right side, you see the detection logic. So a little bit about looping and if checking on the model. And well, then you can have some kind of risks identified by incoming data flow analysis on certain components of certain types and stuff like that. So that's still a more complex kind of rule, but there are even way more complex, but even way, way more simple ones inside. So it's very flexible. As said, you can add your manually identified risks also into the Threagile report. So that's definitely that if you do some kind of threat modeling workshops, you will end up having some risks that no tool can ever identify, more like business risk. And it would be a pity if we were not able to funnel them into the same style of reporting. And you can, of course, add them in the YAML file as well, including even those data breach things and all these different kind of ratings if you want. So editing these models is quite easy in IDEs. So every major IDE can understand YAML. That's quite simple. They do have a technical assets and a trust boundaries view. So here are data assets view, so you can directly jump by clicking in the tree of the structure view of your IDE of choice. And Threagile itself has some kind of schema, some YAML schema available to import into your IDE. It works with the major IDEs. It's just a one-shot thing. And then once it's imported, you can assign that schema, Threagile schema, to that YAML file you're editing, being a Threagile YAML file then. And that gives you auto-linting. So here you see I had a typo in web server. So, and it gives you directly a yellow mark. That's a typo here. That's not in the list of allowed technology values that's available in the model enum. And you even get some kind of code completion, or no, it's not actually code, some auto completion when working and filling in these models. So you can type and hit Control Space, and it pops up a list that you can choose from, and while typing it reduces it. So that's a very nice takeaway of having a very easy way to edit these models in your IDE of choice by importing the YAML schema. And having some live templates that you can just as a snap in, then just being opened, and you can tap through those kinds of things and just hit Control Space, and it's easy. It's like a little bit like Zen coding. If you've done that many times, then it's very fluent in the IDE. Risk tracking, also very important because we need to do something about the identified threats or risks. And every risk, well, possibly you've seen it in a report file here in the pictures as well in the previous screenshots. Every risk has some identifier, a unique readable identifier with some compartments via the add character, and gives you what type of risk at what system, via what data flow to what component and stuff like that. And you can, by these IDs, individually assign a status to those risks. So default, if nothing is done, is unchecked. So then you can set it to in discussion, accepted, or in progress, mitigated, or sometimes as a false positive. That gives you then nicer bar charts, the green ones going up if you are more on the mitigated side then. You can have some text, documentation, justification, something for the exported report artifacts, and you can even use wildcards to group them, but I would not recommend that using the wildcards because you might accidentally group some other risk instances into this as well. So better go for the individual ones. And there's a model macro existing that's also preceding the actual current identified risks into this risk tracking, modifying the YAML file itself. What about bigger models? Yeah. Works even way bigger. That's just a very, very small still one. An example one, of course. And I've seen in real world scenarios, way bigger ones that gives you a quite interesting view of the truth of the data flow and your architecture, because it's built bottom up by the development teams. And that's the auto layout, how it's being directly created, and sometimes also useful for debugging production issues. It's not only about threat modeling. So that component is talking to this. That's an interesting thing here. Something like that. Good. There's a REST server available. As said, it's not only a CLI. You can start the CLI in server mode, and then it's giving you a REST API and a little bit of a web UI, but just to have some documentation stuff there. And there's a playground online run.threagile.io. That's just the Docker container you can pull and run if you're into that. And in this REST API, you can also interact and let this model process happen. I've mentioned the term model macros a few times now. What's a model macro? That's like an interactive wizard. So it's something like a question and answer kind of thing. So it is useful for having a way to do some repeating of similar model tasks, like adding a build pipeline to the model. It's about code backdooring. Here's some supply chain attacks and stuff like that. So it's also very important to have the build pipeline, how your architecture, your components are built and created, and how they are deployed, and where the artifacts are stored, and where the data, your code being data, your deployment units being data, is flowing, because it has a very high integrity rating. If the attackers manifest in an architecture and modify a build pipeline, they can backdoor code. And that way they can backdoor your production systems, getting a code execution on all your production systems by taking over your build pipeline infrastructure. So that means that needs to be taken into account of the risk landscape as well. And that's often underestimated in threat modeling. So that's something that should be in every threat model, but it's many times similar. And that's a good candidate for a wizard, like a model macro, to have an existing model, read that, and then asking you, the modeler, questions about how you want your build pipeline to be added to the model, then adding it, and then you can continue modeling the YAML. Or for doing things like adding a vault, identity provider, those repeatable things. And also for seeding the initial risk tracking. And you can also add your own model macros if you want to. Skipping the demo due to time, but that's something we have in the slide here as well. So that would be a model macro to add a build pipeline. So here we can add a build pipeline, and we are having some questions asked here. What product is used, just for name, it's just for labeling, just for the title for this box on the model. And how are you building your software? Are you using an artifact registry, and are you using a containerization environment? What is your deployment style? Is it more push-based or pull-based deployment? And so 10 to 15 questions, something about that. And even then you can, here in this example model, you can, very simple, small one, you can have a multi-select on what kind of components in your model are you deploying. So what component basically contains something that you create, custom created software or plugins or stuff like that. Is it in a trust boundary, the build pipeline stuff? If yes, in which kind of type? And are you using push or pull-based deployment style here? Or the GitOps one, if it would be pull-based. And then it's doing a dry run and giving you here a thing of a list of what's being added to the model, and including the technical assets, the data flows, the components, all these things, the trust boundaries. And it says, no, change set valid. So shall we apply that to the model? Yes, we will. And then you get a new model that you can then, again, use as the base of your development in this threat model. And you can also manually then again take over again. And then on this example model, you see the 2/3 on the left was extended by the third on the right, which is actually the build pipeline, a cluster environment management thing for container orchestration, a build registry, container registry development client, also very important to safeguard that, including the data flows to the production components that this thing is deploying to based on your answers. So that's a nice example of a model macro. So it's a way to automate certain model things, certain model modifications on a wizard style. Well, the Github integration is existing. That's also quite nice. So you can use, if you're using GitHub workflows for building your software, then you can, or for doing whatever you want in your GitHub thing, then there's an official, there's a template existing that you can just clone, and an official Fragile GitHub action that you can use as part of your job description, your workflow job description. And then every time the model file gets pushed to the repo, the Fragile action runs in the background and creates those nice artifacts. And if you want to link that on your GitHub repo, then could be a private GitHub repo or a local on-prem one, then you can also have the diagrams or the report artifacts, whatever you want to do with that, linked to that. Okay, so what are the possible, hopefully, the possible effects of that kind of threat modeling as code, or agile threat modeling? Well, it's more declarative than code. So custom risk rules can be used to analyze the model graph, augmenting those 40-ish existing ones. So that's useful for big corporations to have some individual policies applied to their projects. Like certain network areas where certain components must never be, or these should be there. And when speaking this component to that component, then there must be some gateway in between, stuff like that. You know, all those corporate kinds of policies. And augmenting the existing rules. You can get a uniform documentation of your system landscape, if the projects are using that, built bottom up by the dev teams in their IDEs, along with the code base. And that's where the truth lies. So you see, sometimes you see possibly a gap between the architecture you're thinking you're existing and having, whether the architecture you're actually seeing and looking at. That's how it looks like, the actual data flows. You can instantly regenerate the risk landscape when something changes on a project, like when you're getting more, let's say, health data via that interface now for the next MVP, then you have a more sensitive data rating, and you might have then more protection things to do, so more risks coming out of that. Or you move a component to the cloud or something like that, you can directly get the delta. It also applies on the breadth of a corporate wide landscape. So for example, when a policy changes, when you're working in a regulated domain, then due to some kind of policy regulation change at some kind of due date, some things must be done more securely. Then if you're having a policy or a risk rule for that, then you can modify that risk rule, or at least then create it to reflect that change. And then you can just rerun the generation of all the different kind of projects, and you would see which of these projects might possibly have some outcome to do and some work to do until that due date. Nice. That's where I'm in CI/CD pipeline stuff. So you can also have something that is more or less automatically running with your build workflow due to the JSON that can be used. That gives you some trend graphs. Are we getting better or worse? And some kind of warning heads up when you're having some automated releasing of features to production, when, for example, it contains some yet unchecked, no one has checked that, high risks. So that at the end, threat modeling eventually will become part of DevSecOps. It would be very nice. That's also something from my side. Security would be then less bottleneck for those sometimes very tedious threat model vetting stuff and sign-offs. So we can take a look more into these workshops and focus on those threats and risks that no tool can ever identify, or the business risks, by having a baseline check automatically be applied. What are the upcoming features? Some of them currently in development. More documentation, yeah, more samples, more screencasts. I've seen very nice big models, so there can be definitely some more examples be created. Web-based model editor would be nice. The REST server, the API does the not yet documented part. The documented part is just for using it, but the not yet documented part, it's not currently in a full final state, is having a very good foundation. I'd say 80–85% of a backend for a REST backend for a possible web-based model editor, that you can also have some UI-based creation of that and directly get the diagrams created to see what you're creating there. Would be nice. Very important, has been many times requested by big customers and users of this thing, is model linking, model includes. So basically having some kind of way to reference different kinds of models and submodels. Idea would be that some users have recommended to have some layered graphs so that you can have a context view where you have the context system, the surrounding systems just as one component, a black box, and you have the connections, or a detailed view where you can also drill down into them. Some ideas are there to seed existing things like having the cloud APIs and seed them by a model macro into the components of a Scratch model, or to have some import from Terraform, CloudFormation stuff. I've seen GitLab doing an integration as well. They do have a ticket online. That's perfect to have Threagile created into GitLab CI workflows. So it has already been done for GitHub from the GitHub action. Possibly will be done by GitLab as well. I've seen a ticket online at least. They're thinking about that. More pipeline plugins. So I've had also some on the talk, some nice feedback. Would be nice to have some LeanIX integration or something like that. We need to look into that, what we can do there. Bug tracker integration, that's something that's perfect. So Defect Dojo or Jira or whatever, to have some kind of more seamless way to funnel the risk findings to development teams in their tool set, that they can then check the things off. Yeah, ticket is closed, we've mitigated that, or we've checked that, something like that. And possibly sometimes also some more drawing-based integrations. There's a nice open source as well, Draw.io kind of thing that might have some interesting ideas there as well. Your feature requests also welcome on the GitHub communication channel here about Threagile. That's the website, Threagile.io, the playground. That's just a Docker container. You can pull it yourself. And there's a community chat on Jitter. The open source, everything's fully open source. MIT license is sitting on GitHub, will ever be. And a container also in the repo, Docker Hub. So feel free to check this out and play with that. And well, look forward for your feedback and Q&A. Hopefully I didn't overuse the time.
Excellent. Thank you very much, Christian, for the excellent talk. And yes, we do have almost 10 or 9 questions. So nice. I'm not sure if we can run all through them, but yeah, that's been really, really excellent. And we enjoyed seeing you talk. There is some question about basically saying, first of all, thank you very much. Awesome work, Christian, and thank you for the presentation. And the audience is asking, what's the necessary threat modeling pre-know-how to use 2 or 3 Agile, like in terms of entry level, because that person hasn't done it before. So what's the best way?
Good one. So first, you need to a little bit understand what YAML is, but that's quite simple, because otherwise you might run into some issues in editing this. And more on the threat modeling kind of thing, it's that you need to understand your architecture. What's a component? The thing you would draw on the whiteboard, like a technical asset being web server, database, and all these things. So you need to understand your architecture and just model what kind of component is speaking to what kind of other component via what protocol and what data is flowing. So as soon as you get into understanding what those YAML things are in Threagile, what they are asking, and that's easily to be learned by playing with the example model. And then you see, you can change things and you see how it reflects in the result. Then you understand how it is, or what it means if you say an asset is encrypted or not encrypted, a communication link is authenticated or not authenticated. And then it's just about modeling it. At the beginning, it's a little bit to get into that, but it will be definitely getting way easier and quicker if you've done it many times. It's the idea of having a rule-based, risk rule-based system to analyze the security perspective, analyze the model. That means the entry level would be lowered because you do not need to be a security expert in doing that. That's where the risk rules kick in. And so as non-security experts, not yet security experts, you can, if you know your architecture, you can model it and see what the result is. So the entry level is actually reduced due to the fact that you do not need to have direct security know-how on that. When you're having security know-how and when you're having know-how about threat modeling, then into your architectures, then you can create your custom rules to even have more outcome of models, but that's for the second or third stage then.
Excellent, thank you, Christian. And that actually leads to the second question quite well from the audience. So what's your experience so far regarding using 3Agile in projects? Who is the main user? Is it the developer, the security analyst, the architecture? Maybe you share some challenges using that.
Yeah, good one. So the challenges is to get the data, to get the input, because you're modeling on detail level. You're not modeling in a constrained canvas in a whiteboard in a physical room and just draw some lines like an architect might think it will be, or like it should be, but you get to know the details. So you need to really need to understand what data assets you're working with, how they are rated security-wise, all the details you need anyway, and what components you're having and what kind of communication links. So that's something you need to get from your developers, at least in terms of what components are speaking to what kind of other ones via what protocols. So the challenge is to get to the details, but you need to get to these anyway if you want to have a good model. And then the main users are, and I've seen different parties for that in my feedback that I got from companies using it. For big corporations, main users are actually the security teams, because the vetting of a project in its project phase in terms of security, vetting of the threat model and sign-off stuff gets easier. So and I've seen that they are creating custom rules to enforce certain policies also, or to check them at least. So the whole security team vetting of things are easier. And I've also seen on the ops side and development side some nice feedback, because now they see how the architecture is really looking, and that helped them, at least from the feedback that I got, that helped them sometimes in some very tough debugging situations. So also this might be a nice side effect of that.
Great, thank you. And there's another question about have you seen as the biggest challenge for Agile teams? And I think probably just refers to both development and security teams to perform regular threat modeling.
Yeah, so in the classic approach, it's the challenge of having that time slot with some security expert and people speaking about that and having the time allotted to that. So that's not done in every sprint. In doing the Agile kind of way, Agile kind of way, the biggest challenge is to get things running in an initial phase. So often you have to create a model after your project has been created. So when you use that tool now and you're having already some kind of project, so then you need to remodel or recreate them in a model. So that's the first biggest challenge, to get that initial thing to some kind of usable state. That means you need to create or recreate some initial models of your existing architecture. And to get over that challenge, the solution would be to start in a very more abstract style and then go more into detail in an incremental fashion. As soon as you have that kind of current state reflected of your project in the model, then it's easy to get the buy-in for the developers to do this very small incremental maintenance step of adding just a few lines of YAML when they're creating a new microservice connection, something like that, in their IDE, because that buy-in comes from the fact that they see what changes in the visual representation. I've seen the model graph really being a good buy-in for developers, that they are having less way and less requirements to document their things that way.
Great, thank you. And there's also a couple of questions around the tool itself. So how extendable is the model itself? Does it allow actually for custom tags?
Yeah, the text system is actually built for exactly that very reason. So you can have tags, and you've seen it in an example here in the data asset. You can put it on a technical asset. You can put it on a communications link, and you also have some artifacts, some metrics being created. What tag is used by what kind of thing? And you can have a naming scheme that, for example, the cloud risk thing, then I do have some kind of tags that I've used in the example, like AWS, Azure, or something like that, and even AWS :EC2, AWS Lambda, something like that, AWS S3, to have some kind of, it's still just a tag, but to have some kind of semantics in that. And some risk rules, they look if they are there after these tags. to have some more detailed or more biased output. So when you're into this kind of cloud or that kind of cloud and you take it correctly, you get more like you need to check for these things or check for that things. So there are risk rules, not all of them. They are more looking at the technical enum values like protocols and types of technical components and stuff like that. But some of them are at least augmenting their results and narrowing their search in the model graph by taking a look at these tags. And that's definitely something you can use as just being a tag.
Great, thank you.
Okay.
Now, there is also a question about the most complex model you have ever validated or you're aware of using 3Agile.
It's just those where I got feedback from. And the most complex one was something that would need to be plotted because it can otherwise not be printed anymore, not at all. And it works. And that's where they said, okay, we needed just then really more than 1 GB of memory. So they increased the container of 2 gigs of memory because the auto-layered rendering was something that takes a few meg of memory, but then awesome output. And they were really surprised how the data flow really looks like. And I expect this effect to be even broader when the threat model submodel splitting and linking feature is available, so that you can then stick together multiple projects via the connections, and you then might possibly get a very big model created from that. So I've seen quite big ones. And in terms of the YAML file, you can split them. That's easy. Splitting a file, that's just simple. And also in terms of the created kind of visual representation, even the big ones look very nice. So I don't know if that's the biggest. Don't get any feedback from those, but the feedback that I got from that one was quite a big one.
Cool. And there's another question whether the result from 3Agile can be used to generate a build breaker if a certain condition is detected.
Yep, you can. So definitely. So there's the JSON output. You do have a stats for the statistics. That's just very, and you can also set it in a mode that it only generates the JSON. So if you don't need the diagram, so don't waste some time on that. But it looks nice. And in the stats JSON, you get just the numbers, how many high or critical high, elevated, medium, low informational risks. And you also have a detailed JSON. And by what category? So unchecked, mitigated, false positive, of course. And you have a detailed one where all the details from the report is also in the JSON. And that means you can have some easy build breaker criteria just based on the stats JSON if you want. So if there is more than 0 high or critical risk, remaining risk, that means it's still in the unchecked state or has not been mitigated at all, then you get a build breaker, or at least some kind of flag build if you want that. And you can also do it in the GitHub action that's available. That's a GitHub workflow action, so you can have your own workflow in this jobs workflow file that you can also use the output, which is the JSON, then to have some decision there.
Great. And there's also a question from the audience in the Zoom chat about the data breach probability. So how is this calculated, and is it using some framework for the algorithm?
It's basically calculated in the risk rules. So every risk rule has some kind of, and you see it best when you take a look at the let's take a look at the example here of a manually added one. That's also something we do have, I think. It's before that. Yeah, exactly. That's something. Point is, let me find that slide. Here you see a manually added one. So manually identified, that's where you see that manually identified risks, they do have the same semantics than the automated identified ones. So they are referencing some kind of exploitation likelihood. Is it unlikely, likely, very likely, or frequent to be exploited, that kind of risk, whatever it is, and an exploitation impact. So would the impact be low, medium, high, or very high? That's giving you the severity then being calculated, and the data loss or data breach probability of being improbable, possible, or probable. So denial of service, definitely even no or improbable, and injection or other kind of remote code execution vulnerabilities, definitely something more on the probable side. And then you can reference the data loss technical assets and the most relevant technical assets where this would then, based on this kind of risk, manifest. And that's exactly where those automated risk rules take care that they try to understand, based on what has been coded in these risk rules, how this basically affects the data assets that are either stored or processed by that component where the risk might manifest. So it's actually in the risk rules.
Great. And there's also a final question. What is the expected percentage of false positives?
Good one. So from the feedback that I got when some users are comparing it to traditional, more general tool-based kind of threat modeling, it's quite low. I was surprised that it was even that low, that they said almost no false positives. There are false positives, definitely, and I've seen them. And I've even put some kind of possible reasons for false positives into the report. So every kind of risk type has check this if it's a false positive. So that means it could be a false positive if blah, 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 blah. So every risk type, every risk has some kind of description, what could be possible false positives for that type of risk to be checked. But from the feedback I got is due to the very technical modeling, and that's where it really pays off to have a technical model in the YAML file. You need to go through the details. What kind of component with what kind of technology, what kind of protocol, is it encrypted, is it not encrypted, is it authenticated, if by what, is it authenticated, and stuff like that. So then you have way less false positive just than by drawing a box and having a few lines connected there, because it lacks detailed semantics, and that might give you more generic risks and that might give you more false positives. So if you have more detailed semantics in the model, which you do have in the YAML file, you get also usually less and more precise results and less false positives.
Excellent, thank you. And there's some more question. I would just probably best just to answer them in the Zoom chat. So don't worry, Christian is going to stick around and answer all of your questions. Yeah. And again, thank you very much for having you here. I really enjoyed your talk, and just really seeing that those using tools like 3Agile can actually help, also just giving developer teams a possibility to do threat modeling without being a security expert, and just having all those predefined rules and some way just to codify that, I think really helps, just really shifting security left and giving it back to developer teams and regularly assess their threat model. So thank you very much for showing us that.
Perfect. Thank you for having me. I'm really proud of that. Nice.
A very short question maybe from me. You at which army did develop that in 1 year? You said last year you had some time, right?
Yeah, it was so it was even in 2019 where I was having some time, because last year it was possibly due to the Corona stuff, more on the lockdown side, but we were easy to work remotely. So our calendar was quite full, usually, I suppose, of you as well. But in 19 and my beginning of 20, I was having lots of travel time, because being a trainer on these topics and doing these workshops, you do have some kind of on-prem things that are going to be coming soon back again. And when having lots of travel time, international wise, well, then you have lots of time with your notebook to do some nice coding. And when you went through those pain points in some projects before, where you see how threat modeling can really be a pain for agile projects and can be bogging you down as a team, then it's easy to come up with nice ideas, and seeing them manifest in something like that. That was really, really fun.
So amazing work.
Thanks.
Cool, thank you. So let's continue with our meetup tonight. What we're going to have now is a quick 5-minute break. And as part of it, we're going to try something new. And after that, we're going to have Johannes talking about MITRE counterintelligence. So what I'm going to do now is just going to share my screen. Everything works out. Okay. So again, we're gonna have a 5-minute break. We'll be back around 8:23. So 5 to 7 minutes. Just take your time, go on the toilet, do whatever you need to do, and come back. And if you have some time after, just join on another vote. We'd just like to know in the meanwhile on what sort of security topics would you actually like to hear from our OWASP Frankfurt meetup. So we had Christian talking today about threat modeling. We're going to have awesome threat intelligence-based talks. Maybe there's something you want to learn more in terms of cloud security, DevSecOps, even like physical security, which we had a while ago. It was really good, excellent talk. Please let us know. Just go on slido.com, join the 4711, and let us know if there's something you want to hear more. And see you back in 5 minutes. Great. That looks like quite an interesting outcome. Johannes, what do you think?
Oh, let me see.
Can you see? So it looks like we have
nice.
maybe a bit biased from today's talks, but it looks like we have a strong interest in offensive security.
So it was worth it to open 20 tabs in private mode and vote for offensive security.
all your votes. Well, it's interesting to see that cloud security and DevSecOps is also something people want to learn more, as well as defensive security. So definitely, if we're happy to have more speakers in that, like same as Christian, joining our meetup. If you have somebody, or if you want to give a talk yourself, just feel free to reach out to Johannes or me and let us know what you'd like to talk about. Send us like a bio and an abstract, and we are really happy just to welcome you here. And there's also a possibility for you just to give a lightning talk. So even if it's like 10, 15 minutes, if there's something you really want to share, please reach out to us and we're happy to welcome you. Okay. All right. Let me welcome you, our next speaker. And as we probably all know himself, Mr. Johannes Schönborn himself, he's one of the founders and the main organizers of the OWASP Frankfurt Meetup that's been always going on for over 10 years. And yeah, hats off for that already, organizing that meetup for such a long time. And he's also the director of Exploit Labs. And Johannes actually brings over 15 years of experience in cybersecurity, specializing both in penetration testing, digital forensics, as well as application security and incident response. And actually, he's assisted some of Europe's most prominent banking, telecommunications, and chemical corporations by discovering vulnerabilities, as well as fending off costly security breaches. Johannes, are you ready to talk?
I would hope so. Thank you. Thank you.
Awesome. I'm going to give you the screen and feel free to go ahead. You're looking forward.
So let's see, slideshow start. You should see the slides now, right?
Just said you have started screen sharing, double click to enter full screen mode. Can't see your slides yet.
Oh, that's good. Let's try that again. Can you see it now?
Can somebody else see it? I cannot see it. Nope.
Okay, let's restart sharing.
Yep.
See, it's always little things that go wrong. Let's take this window. So I hope this is better.
You have started screen sharing, double click to enter full screen mode.
Let's do the totally OPSEC safe thing now, not just share the screen. What can possibly go wrong?
Close all the 20 tabs.
Yeah. So now slides, right?
Can somebody see the slides? Please feedback. Otherwise, Johannes, if you want, you can just send me the slides and I can just try to share them.
Yeah, let's do that. Great. Great success. Do
you think it's because of the laptop or?
Oh, well, it worked very well the other day.
Can happen. Sometimes I feel the same, like having tech aura and then nothing works. Yeah.
Then I will just send you an email to your OWASP address.
Okay, of course. So guys, maybe you can just even continue on the vote if you haven't had the chance to vote for your preferred security talk. Just please submit your vote, and then I'm just gonna go and open the presentation for you. Let me know when you send it.
Yeah. It's in the ether.
If you don't mind, I might just import it into Google Drive because I don't have PowerPoint.
Yeah, sure.
Yeah.
So anyways, can I really start? There's a little chit chat on it. So as we already talked a little bit before, we have a pen test team of like 8 penetration testers, and we're moving from penetration testing to red teaming, and are discovering over the last years what that means beside buzzword bingo. So while usually you would do your pen test against a web server or an internal pen test where you get access to a network, on the red teaming side, it oftentimes becomes a cat and mouse game between you having a phishing attack launched and someone is clicking on your malicious Word document, and then the chance that what you spawn actually survives and is not caught by the antivirus, the endpoint detection and response, is not somehow affected by sysmon monitoring, and the blue team just comes running with a taser and kills the person that dared to open your link. And you learn a lot about OPSEC, operational security, and and the next buzzword coming on then counterintelligence. So usually counterintelligence is like spies against spies. And now that is a little bit, as so many other things, you just put cyber in front of it and then it becomes something that's more or less relevant in the cyberspace. And for us as a red team, it simply means, how can we better understand what we're actually facing, what are the blue team capabilities. So maybe just, and I'm also working in the European Network Information Security Agency's working group on cyber threat landscapes, because that is then also simply a learning topic for me and for our team to better understand how can we provide value to the client by not simply going in, again, trying to become domain admin and say like, hey, cool, we're done. But to understand like who's actually attacking them, how would they do it, how feasible is it that it will work, how feasible that they will circumvent security controls or simply take a different attack path. So so today we will become the advanced persistent threat happy turtle, and we are targeting a power plant, PP, and our mission is to disrupt the power plant. And we did our due diligence and open source intelligence, and therefore we know, for example, Robbie is an operational technology operator, and the power plant is using the new fancy Siemens, whatever web app controlled remote heating system. And we want to disrupt that as long as possible. So that's like a little bit of the setting that we have. And on the agenda that's up next, we will simply go a little bit through MITRE, how we would map what we will be actually doing. And then in the second part goes through MITRE Engage, which is replacing MITRE Shield, and will let us see a little bit what the defender has for further options to raise the resilience against an attack. And then in the third part, how that enforces us to change our attack playbooks to be aware of this. So it's like a mind game on top of a mind game, because as of today, if you're aware of MITRE attack, you're already ahead of the curve in testing. And then to add there, MITRE attack is a nice thought experiment. And then we have a key takeaways. Yeah, so MITRE attack on the next slide. Next slide. So this is basically mapping MITRE attack. You see on the bottom left has different categories, and it maps as an APT what is the APT all capable of doing. So you see here all what's marked in blue is things that were observed of that APT doing. And now you can imagine if you select not just one APT, but 5, 6, or 7, you get a nice colorful overview with certain heat points where certain APTs have the same capability. So before red team engagement, we would ask ourselves, probably backed up by proper threat intel, which attackers would attack this client? How would they do that? Would they, obviously they will do phishing because everyone does phishing, but what would they do next? Will they go for a vanilla pirated covert strike beacon, or will they bring in their own stuff? Will they then do lateral movement via what Cobalt Strike does, or will they go via WMI, system utilities, will they go via PowerShell, what will they do? And therefore that differentiates every engagement a little bit, and also from a technical view for the client that controls where he should focus on. So on the next slide, we have an example, a very simple one, browser bookmark discovery. So the category discovery has 27 techniques, and one of them is the attacker is able, once he has a foothold on your system, to read the bookmarks of your browsers and to see what's in the safe credentials, for example. It's very, very simple. But from a red teaming perspective, you also don't want to overlook that, because if you get in, like in your regular pen test, and you say, hey, I'm a domain admin, I don't care about anything else, you will miss this. So on the next slide, then we have like a little playbook. So as a pen tester or red teamer, once I get foothold on a new system, I would first enumerate the local browsers, Firefox, Chrome, Edge. Then I would extract the history from there. I would extract the password from the browsers. I would add that to my loot, like, hey, you hooray. And I would remember there's actually a goal why I'm here, and that is to find the OT control interface, because for whatever reason, we are aware that there's a web app for that. And if I find that, then obviously I also want to identify, do I actually have the right credentials for this, or do I need to look in another place? And then you have certain methods how you get that, Metasploit, whatever. And here marked in yellow is very interesting that MITRE attack says this type of attack technique cannot be easily mitigated with preventive controls, since it's based on the abuse of system features. We'll get back to that. So on the next slide, basically what that means is you have a history, and there it says heating controls.kplant, and it has credentials in it, and you do your little happy dance, because that probably means that you're going to reach your goal very easily. And there was not much the defender could do at that moment. It's not like you cracked a password to do that, and it's not like you compromised a domain controller to do that. You didn't even need to do that. You just sent the phishing mail to the right guy, for example. So next slide. And what could you potentially do now if you don't have a technical defense? And on the next slide, we see MITRE Engage on the big picture is again more or less like MITRE attack, a whole framework. And we will focus a little bit on the middle, where it says artifacts and decoys and honeypots. But also, if you look at MITRE Engage as a whole, MITRE Engage tells you, as a defender, you should have a better understanding of who is attacking you. So MITRE attack is all about TTPs. It's about techniques, tactics, procedures. It's all technicalities. It says, don't let your stuff be stored unencrypted. Be aware that someone is doing DLL hijacking and all of these things. That's all cool for the technical stuff. MITRE Engage says, actually come up with a persona and a storyline and a threat model, like who's attacking you? Why are they attacking you? What's the likely attack path that they take? There's Robbie, the OT operator. How would you protect him? And that doesn't need to be just technical things. And on the next slide then, it says, for example, decoy artifacts can take a variety of forms, including credentials, accounts, files, directories, browser extensions, browser bookmarks. Decoy systems can be real, virtual, or simulated. And that's now where it gets a little bit scary for the red team, because on the next slide now, I need to adjust what I do, because as we are now aware of a red team that MITRE Engage exists, we need to ask ourselves, can we go on like we did before, or are you now entering here the cat and mouse game? So I don't know when I start my engagement, depending on how the offering and what's the project setting, I might not know what I'm expecting, what defenses I'm looking at. And therefore, we need to adjust what we just saw in that orange table. So if we go to the next slide, these are our capabilities, as we said. So this is an example from APT 28, and everything that's marked blue is something that they can do. So naively, if APT 28 would be relevant for the engagement that we have, we would say, let's do at least the blue stuff, even if maybe some of the white stuff is much more easier for us to do or would yield the same result concerning the goal of compromising the company, but we want to simulate exactly this. But now for more or less every of these steps or some of these steps, I need to think, can I actually do this in a safe manner? Or if I do that, will I trigger something? That I trigger something is probably okay, because I also want to see at some point if they have something in place. So I can also tell them, yeah, good job. You did kill us 15 times and we didn't reach our goal. But probably we would like to have that at the end of the engagement and not at the start of it. And therefore you need to become somehow aware of what's going on. So on the next slide, we now see a little bit of an addition. So for all these playbooks, you now need to go back and cross-reference MITRE Engage. Is there something in that framework? Or obviously also ask yourself, even beyond Engage, is there something that they could do? So for example, now you should be aware that you compare the browsing history between the three browsers, and you compare the credentials between the three browsers, and you look for certain things that stand out. So for example, if only one of these browsers has a set of credentials to the heating plant, and the credentials look very different than the credentials that are used in the other browser for all of the other things, like the intranet, the time accounting, other power plant related stuff that is maybe not exactly the goal that you're looking for, then maybe you don't want to go there and use these credentials you found in the other one. And yeah, so if we have a look at the next slide, there's an example, very basic stuff. So in the Firefox, you see heatingcontrols.kplan with the browser credentials xn number, and a very hard password. So if you glance at that, you would say, hey, cool, that's probably the personal number. And of course, they have a certain password policy, looks fine. Let's check out if we can log in with that. But then maybe you realize that in Firefox, there's nothing else happening, or only very few things. And Edge looks more like the main browser of that guy. And you have something that could also be relevant for you, like maintenance.kplan. And there it looks like a Active Directory login. Then maybe that might be more relevant. And maybe you find 25 other websites that use the same browser credentials. And therefore that might reinforce your understanding that probably they're not using your personal account details for the honeypot, because that usually comes with certain downsides. And then you could start cross-referencing over other hosts that you maybe successfully attacked, and look, for example, is that XN number always the same? Because that might be a limitation of the honeypot. And yeah, so the mind game goes on. Next slide. So the key takeaways. Basically, MITRE Engage, MITRE Engage will augment the red teaming part. So as we know, obviously you are aware already before that a client can have certain monitoring. He can have a honeypot. He can have this. He can have that. But now this is all nicely laid out for us to understand, and in a depths that we probably wouldn't go so deep ourselves. That means also you need to be aware that even if there's no security control in place that prevents you from doing something, that doesn't mean that you will not trigger an alert or that you move into a trap. So it basically reduces the speed at which you work a little and makes you think a little bit more, double check certain things, which is cool for us because that immediately raises our own maturity of not running around like the Russian bear and just doing whatever you can, but to step back a little bit and think more about what's my goal. Do I really need to do this? Do I really want to do this? Which goes so far that we have, for example, Cobalt Strike, how do you say that? Like Cobalt Strike implants, where you type a certain command and you hit enter and it asks you, are you really sure you want to do this? Like that little, how do you say that, Karl Klammer pops up from Office and says that's, yeah, probably not a good idea. And also, if you identify something like that, it also makes you aware that you need to think ahead. Like if they have a honeypot in the browser, do they also have it in Active Directory? And yeah, so we're looking forward to get more of these, to actually see that in a client engagement. Also, there are other parts in MITRE Engage which you can also use to better reinforce your recommendations. So, for example, if you go back and where I said that you have these storylinings, those personas, the threat modeling, you can obviously tell them, well, if you would not just have made the red teaming engagement, but if you would have gone back and do a proper threat model, you would be already aware that XY% of your budget spending goes into areas that are not necessarily very beneficial for you, looking at who's most likely to attack you. So maybe you want to reprioritize, your spending. So that's what you see on the right side of the slide, the prepare phase was developing a threat model, persona creation, what's the strategic goal, what's the storyboarding. And that's very interesting for us because it helps us add value in the engagement. Yes, and I think that's already it for the short listening talk. On the last slide, I put a few links. So for example, Black Hills has a webinar, OPSEC Fundamentals for red teams. CEFCON has a talk. I don't remember who did it, but the slides are linked there. And there's a random military-style counter-cyber threat intelligence course on Arizona University, I think. Probably need to work a little bit harder to get access to the materials, but it's possible. And yeah, that's so far for the listening talk.
Great, thank you, Johannes. And there's actually a couple of questions from the audience. And the first one is around Red Team Attack Book. So which Red Team Attack Book do you find the most useful?
That's a good question. We actually run our own. And the playbooks, which is a common term, the playbook simply makes sure that each of our guys does more or less the same, and we have an understanding within the team what actually means lateral movement, what actually means analyzing a domain, what kind of information are you looking for. So I think I can look up there's some examples, but it's mostly about making things repeatable and also transparent within the team. Can be as simple as a playbook for a vulnerability scan. How do you configure Nessus? Do you go for all ports or for the standard ports? When do you go for all, when for the standard? Do you always want to scan for UDP? In which case do you just scan for 2-3 ports because you want to be at least a little bit stealthy? And that's what the playbooks are for.
Great. And there is another question around ransomware. Did you ever try to simulate a ransomware attack in your production environment using that?
Yes. We usually use a very defanged version that basically simply touches a lot of files and either modifies them or renames them. So yeah, that's the easiest way. So I usually don't like to do that because however you do that, from my experience, someone will freak out about it. Someone was not involved in it. And yeah, not our core competency.
Okay, thanks for sharing. And there's also another question on difficult attacks to detect. So which ones do you think are the most ones to difficult to detect from your side using MITRE?
I think the most difficult to detect are always the things that don't create any noise or that don't stand out. So, for example, as long as you can stick to the living of the land, or even as much as to just land on a system and just lean back and see who is it, what is he doing, what browser is he using, then I use the same browser. That's almost impossible to detect. So from my experience, I would say either you're detected in the first few seconds automatically, or you're detected when you move on, when you move laterally. So if you take your time in between and you just figure out where are you already where you want to be, and you don't use tools like Bloodhound to create a lot of queries, you're fine. So everything that is not involving additional tooling that you need to bring, that you need to deploy, I think is the hardest to detect.
Excellent. Okay, I think there's no more questions from the audience. At least I can see that. I think there's, oh yeah, actually there's something coming in. What is the difference between MITRE Engage and MITRE Shield?
Yeah, that's an easy one. Engage replaces Shield.
Okay, just so superseded.
Yeah.
Awesome. Yeah, I think that's, if there's any more questions, I think there's one question about automated web security testing. Any suggestion for using OWASP, apart from OWASP app? I think that's more a general question. I'm happy just to provide the answer afterwards in the chat. Okay, and yeah, again, thank you very much, Johannes. Really looking for, it was really good just to have you talking, after being host for so many times. And I think, as you said, this is really bridging the gap between what Christian said and where you're getting at is really, if you do proper threat modeling in advance on the blue team side, you could more likely detect those sort of attacks. And at the same time, from the red team side, you want to really think about how the defender would perform a threat model, what sort of threats they are. So really enjoyed.
Also, more and more often it becomes we see that we come in with a test after a ransomware attack, for example, and therefore it's not a benefit to show them that you find some way to do something, but it's more about showing the relevant way. Like, is it possible that ransomware will hit you again? Yes, no, maybe. And ransomware operators operate differently from a red team.
Great, thank you. Awesome. Let me just switch my slides. Okay, again, thank you very much for the talk, and yeah, looking forward for more future talks around threat intelligence. Okay, can everybody see my screen? Cool. All right, so just a quick outro section. I'd just like to discover is just our next meetup and what we're gonna see in where we're gonna go with this meetup. So again, thank you very much for attending. Please stick around for a couple of more minutes. Johannes and myself, as well as Aaron and Christian, will just be happy just to answer some further questions. You can follow us on Twitter, OWASP_Frankfurt or OWASP_DE if you just want to follow us. The meetup page. The Slack is what I mentioned before. We have a reactive Slack channel. Just join that, slack.owasp.org. There is over 5,000 people being active on that Slack. So if you have any questions around any OWASP material, feel free to join and just ask questions or just contribute yourself to OWASP. Now, just covered that. There's some benefits joining OWASP. I think we can just skip that. Just join it if you feel free. You want to go get some access to a Gmail account and also get more benefits from the community. Now, for our upcoming OWASP meetup, we haven't have a final date yet, so that's likely going to take place in 2 to 3 months, more likely after Christmas, because Christmas is going to be busy. Let's see, maybe have a Christmas OWASP edition. Again, if you want to hear more about certain types of talks, or if you want to give your talk yourself, get in touch with Johannes or me. Let us know. We're very happy to host you. Also, if you're interested in having further talks like Christian or Aaron, just in more specific areas, please let us know. What I'm going to do now is also going to do a quick feedback form if you want to submit that, and just let us know what you like and what you didn't like. Also, a reminder that the videos and slides are going to be uploaded in the next couple of days, likely going to take a week. So just stay tuned for that, but they will definitely be up there. As I said, I will leave a feedback form for you just to submit things that you think are good or something you didn't enjoy. Please let us know, because we really like to do this for you. So you have some interesting talk, something to learn on. Also, if you have anything else, just give us feedback on. Please reach out and do that. Again, this is going to be via Slido, so I'm just going to leave it open. And I think now, Johannes, it's time for the after party. And beer is good.
Yeah, just looking around. I guess everything here is empty. What happens when you have the team over? Nothing is left.
Yep. So yeah, I think let's stop the recording first, Johannes.
Yeah, that sounds like a plan.